So today the topics which we are going to discuss is the law of mass action, equilibrium and its types, and equilibrium chemical process. What is dynamic equilibrium? So we'll discuss overall all the types of chemical equilibrium and the most important the law of mass action and what are the characteristics of the equilibrium constant we have. Okay, so going to our chapter, first of all, I want to know how many you all know that what is irreversible reactions and what is reversible reactions. Irreversible reaction. The first point I want to discuss about the irreversible reaction is it proceeds only in one direction or only in, I can say, forward direction. It proceeds only in the forward direction. Yes. Second point I want to say that about irreversible reaction, that reactants almost consumed in this reaction. I'm not saying 100% consumed. Okay, reactants almost consumed to form the products. Okay, third point, reaction proceeds from reactant to products. Reaction proceeds from reactants to products only, but not, we will not get the we will not form reactants from the products. That is one of the case of the irreversible reaction. Okay, next one, if you go to the reversible reaction, what do you mean by reversible reaction? That the reversible reaction proceeds in both the direction, means from reactant to product as well as from the product to reactant. Reversible reaction proceeds in both the directions. Okay, next if you go, reactants and products are not totally consumed here. Reactants and products will not be totally consumed in reversible reactions. Okay, now in reversible reaction what happens? Remember, at one point both the concentration of reactant and product, both the concentration of reactant and product will be or will become constant. At some point of time, what happens? The concentration of reactant and product will become constant. That point is called as our equilibrium point. That point is called as equilibrium point. So coming to equilibrium, what I said equilibrium, that where the concentration of the reactant and the product in the reversible reaction becomes constant, that point is called as equilibrium point. Now in generally equilibrium is dynamic in nature. What is dynamic in nature? Generally dynamic means never stops, or it is continuously going on, continuously steps are going on. That process is called as dynamic process. So here equilibrium is a dynamic nature. For example, suppose I am having a bucket, okay, and here some tap is there. So from this tap water is flowing, from this tap water is flowing, and the level of the water is up to like this here. Okay, now I have making one hole here. This is the hole from where the water is coming out from the bucket. Suppose there is a hole where the water is coming out from that hole. So my intention is that suppose the flow of this water from the tap and the flow of the water from the bucket, suppose they are same, means the speed of the water coming from the tap and the speed of the water coming from the hole are same. Okay, then can the level of the water will change in the bucket, or will the level of the water will change in the bucket or not? Basically no. Why? Because the flow of water from the tap is equal to flow of water from the bucket. So these two are same, then the level of the water inside the bucket will never change. Here you can see that the level of the water is constant. The level of the water inside the bucket is constant, but the process is going on. The process to flow the water from the tap and the process of flow water from the hole is going on. So I can say this process is dynamic process. Why? Because process is continuously going on. The flowing of water on the both the end are continuously going on. But what happens here? The level is same. The level is not changing. Okay. So this process we will call this dynamic process. Like that, equilibrium is also a dynamic process where the continuously of the reaction will take place. Means reactant will convert into product and the product will convert into reactant. Okay. So what I am saying that concentration of the reactant is constant, concentration of the product is constant, then at that time equilibrium will be attained. Suppose I am taking a graph between concentration versus time. Concentration versus time. Okay. So initially the reactant is having more concentration. So after some time it will having some less concentration, it will like this. Okay. And next, initially the concentration of the product will be less, and after some time it will have some concentration. Now you can see that the concentration of the reactant and the product are constant here. It is not changing. The concentration is not changing. So I can say that here equilibrium has been attained. Equilibrium has been attained since the concentration of the product is not changing. This graph I can also have like this. This is a concentration versus time. Suppose the reactant is like this and the product will be, the graph can be like this. So it may be here, it may have the same concentration, but since the concentration is changing, and here after the intersection point the concentration of the product is increasing and the concentration of the reactant is decreasing, so I can say that equilibrium has been attained. But here in this graph, if you see, no intersection point is there, but the concentration of the reactant is decreasing and is going to the constant value, and the concentration of the product is increasing and going to the constant value. So here also I can say equilibrium has been attained. So remember that in equilibrium, what happens? That concentration of the reactant will be equal to the concentration of the product. Okay, Dheeraj. See, what I am saying that at equilibrium, what happens? The concentration of the reactant are constant, and the concentration of the product will also be constant at equilibrium. After, because if the reaction is started, then after some time, what happens? Here, since it is a reversible reaction, reactant will give the product will give the reactant. So if suppose the concentration of the reactant and the concentration of the product are constant, then equilibrium will be attained. I can say at that point equilibrium has been attained. So if you see the two graphs here, what is the difference between two graphs? You can see that here at this intersection point, the concentration of the reactant is equal to the concentration of the product. But equilibrium has not been attained here. Why? Because since the concentration of the product has been increasing and the concentration of the reactant has been decreasing. Okay, equilibrium has not been attained at this point. Equilibrium has been attained at some point of here, where the concentration of the reactant is equal to the concentration of the product. Okay, now come to this graph. Here, no intersection point is there, but still I can say that at this point you can see the concentration of the reactant is equal to the is constant, and the concentration of product is also constant. Both the concentration of the reactant as well as product are constant. So I can say that here also equilibrium has been attained. If here it is attained, then here also it is attained, because both the concentration are constant. Okay, so here in chemical equilibrium, what happens? That the concentration of the reactants and the concentration of the products will be constant at equilibrium. Okay. Now, if you go rate versus time, what do you mean by rate? Rate means speed. So, speed of the reaction. Okay. So, here, suppose I am having A plus B gives rise to C plus D. Some reaction is there. A plus B gives rise to C plus D is there. Okay. So, we will define the equilibrium reaction as once equilibrium attained, what is the need to be dynamic and how will be dynamic? Because the reaction should proceed. Equilibrium is attained means reaction will not stop at that place or at that time. Okay, reaction will proceed. Product will give the reactant, reactant will give the product. Okay, that's why it is dynamic in nature. If the reaction stops, then what is the meaning of having the equilibrium? Okay, so reaction doesn't stop, it will go on at constant value up to long time. Okay, clear, Dheeraj? So A plus B gives rise to C plus D. Some reaction is there, suppose. Okay. So going from A plus to B to C plus D means reactant is giving the product. It is called as the forward reaction, and RF is called as the rate of forward reaction. Okay. Now C plus D is giving A plus B. C plus D is giving A plus B. So it is called as the backward reaction, or RB is called as the rate of backward reaction. Understood? What is the rate of forward reaction? What is the rate of backward reaction? Okay. So rate of forward reaction means the speed where from the speed where C plus D is formed from A plus B. RB is called as rate of backward reaction, where it is called as the speed from where A plus B is formed from C plus D. So at equilibrium, what happens? The rate of forward reaction will be equal to rate of backward reaction. At equilibrium, the rate of forward reaction will be equal to the rate of backward reaction. Means the speed of the reaction on the both sides will be equal. So I can say that, suppose I am taking here rate and here time. Okay. Now it is the reactant, the rate of the reactant, and it is suppose of the product. Then the rate of forward reaction will be equal to rate of backward reaction. So velocity will be same or speed will be same at equilibrium. Okay, understood all of you? At equilibrium, what happens? Rate of forward will equal to rate of backward reaction. Now we will go with the law of mass action. What does law of mass action tells that? Suppose I'm having reactant as A plus B gives rise to C plus D. Okay. Now the rate of forward reaction is equals to concentration of A into concentration of B. And the rate of backward reaction is equal to concentration of C into concentration of D. It is proportional to concentration of A into concentration of B. Or if write equals to, then I can write have a constant Kf, and here it is a constant called as Kb. Okay. So at equilibrium, what I am telling? At equilibrium, rate of forward is equals to rate of backward reaction. So I can write Kf into concentration of A into concentration of B is equals to Kb into concentration of C into concentration of D. Okay. Now I can write Kf by Kb is equals to concentration of C into concentration of D by concentration of A into concentration of B. Okay. Now this is one forward constant. This is the backward constant. So constant by constant is again a constant. So I can write Kc. Kc is equals to concentration of C into concentration of D by concentration of A into concentration of B. This is the term we will call as equilibrium constant. Kc is called as equilibrium constant in terms of concentration. Okay, so I can define law of mass action as the ratio of the concentration of products to the concentration of reactants, the ratio of the concentration of products to the concentration of reactants raising to the power of stoichiometric coefficients. Stoichiometric coefficients is called as law of mass action. How means, suppose I am having reaction like this: Ma plus Nb gives rise to Pc plus Dd. These are the M and Pd are all stoichiometric coefficients. So for this one, I can write Kc is equals to concentration of C to the power of P, concentration of D to the power of small d, concentration of A to the power of M, concentration of B to the power of N. So this is the Kc value for this reaction. So these stoichiometric coefficients are now to the power of the concentration, you can see. Okay. For suppose I am having reaction like this: N2 plus 3H2 gives rise to 2NH3. N2 plus 3H2 gives rise to 2NH3. So for this, Kc will be equals to concentration of NH3 to the power of 2, concentration of N2 into concentration of H2 to the power of 3. So like this, we will be writing the value of the Kc. Okay, understood? Generally for solids, the concentration will be equals to 1. For example, I am having CaCO3 gives rise to CaO plus CO2. This is a solid, and this is a gas. Okay. Now the Kc for this one will be is equals to, generally if you write concentration of CO2 into concentration of CaO by concentration of CaCO3. But what I told, for solids the concentration will be equals to 1, means the concentration of CaO is equal, because it is solid, the concentration of calcium carbonate will be equals to 1 because it is solid. So I can write for this reaction Kc will be is equals to concentration of carbon dioxide only, because of calcium oxide and calcium carbonate is equals to 1. Okay, so like this we can find the Kc value, equilibrium constant for concentration. Any doubts? Next, factors affecting Kc. Okay, so I am having PCl5 gives rise to PCl3 plus Cl2. Suppose this is the reaction. For this, the Kc value is equal to K1, suppose. Next, I can write 2PCl5. 2PCl5 gives rise to 2PCl3 plus 2Cl2. For this, Kc is equal to K2, suppose. Now, what is the relation between K1 and K2? What is the relation between K1 and K2? So for K1, I can write concentration of PCl3 into concentration of Cl2 by concentration of PCl5. For K2, I can write concentration of PCl3 square, concentration of Cl2 square by concentration of PCl5 square. Yeah. So this one I can write K1 whole square. K1 square. So K1 is equals to root K2, or I can write K2 is equals to K1 square. So what I'm telling that if you are multiplying the reactant and product with a number, if you are multiplying the reactant and the product with a number, then the K value will be to the stoichiometric coefficient. The K value will be the same as the number which we have multiplied. It will go to the stoichiometric coefficient, will go to the power of the new K value. Okay, understood? So here how we are writing K2 is equals to K1 square. So multiplying with 2, the total reaction, then I am getting like this. Okay, next. Suppose I am having H2 plus I2 gives rise to 2HI. So this Kc is equals to suppose K1. I am reversing the reaction. 2HI gives rise to H2 plus I2. Same reaction in the reverse form. So here suppose the Kc is equals to K2. Now what is the relation between K1 and K2? So for this reaction I can write K1 is equals to concentration of HI square by concentration of H2 into concentration of I2. For this reaction I can write K2 is equals to concentration of H2 into concentration of I2 by concentration of HI square. Okay, now if you can see, this will be equals to 1 by K1. I can write 1 by K1. Yeah, so if you are reversing the reaction, then the new equilibrium constant value will be the, what is that, will be the 1 by K1. The new equilibrium constant will be 1 by K. If you are reversing the same reaction, you will get 1 by K. So relation between K1 and K2, I can say that K2 is equals to 1 by K1 or K1 is equals to 1 by K2 here in this reaction. Okay, next, in terms of partial pressure, okay, suppose I'm having A plus B gives rise to C plus D, the reaction. So Kc will be is equals to concentration of C into concentration of D by concentration of A into concentration of B. Generally, we know according to Boyle's law that PV is equals to nRT. Means P is equals to N by V RT, or I can write P is equals to CRT. P is equals to CRT, and number of moles of volume is concentration only. So basically Kp is written as, for this reaction Kp will be is equals to partial pressure of C into partial pressure of D by partial pressure of A into partial pressure of B. This is the expression for writing the Kp value. Kp is equals to partial pressure of C into partial pressure of C to the power of partial pressure of C, partial pressure of D by partial pressure of A into partial pressure of B. Okay, now partial pressure P is equals to, I can write CRT, means concentration of C into RT by concentration of D into RT by concentration of A into RT by concentration of B into RT. So all the RTs got cancelled here. So this will be is equals to Kc. This is equals to Kc now. So for what is the relation between Kp and Kc? Basically, the relation between Kp and Kc is Kp is equals to Kc into RT to the power of delta N. Kp is equals to Kc into RT to the power of delta N, where delta Ng represents, but delta Ng, this is one, delta Ng represents number of moles of products minus number of moles of reactants. Delta Ng is equals to number of moles of products minus number of moles of reactants. For suppose example, let us take N2 plus 3H2 gives rise to 2NH3 is there. Okay, so Kp is all our gases. Kp is used only for gases, not for solid and liquid. For solid and liquid, the partial pressure will be equals to 1. So Kp I can write partial pressure of NH3, since stoichiometric coefficient is 2, I can write square. Next, partial pressure of N2 into partial pressure of H2 whole cube. So this one I can write partial pressure P is equals to CRTS. So concentration of NH3 square into RT square by concentration of N2 into RT into concentration of H2 into RT whole cube. Okay, so this one I can write concentration of NH3 square, this is cube, concentration of N2 into concentration of H2 whole cube into RT, here square is there, here 4, here to the power of 4 is there. So I can write RT to the power of -2. So this is our Kc into RT to the power of -2. Okay, so easily you can find, if you know the relation, that Kp is equals to Kc into RT to the power of delta Ng. Now what is the delta N value here? Products is number of moles of products are 2 minus number of moles of reactant, here 3 plus 1 4. So 2 minus 4 minus 2 means I can write Kp is equals to Kc into RT to the power of -2. The same thing what we have find here. So finding the relation between Kp and Kc in a reaction, how can you find? By like this. So you have to see that you're writing the same thing, then you can know. So see that all are gases or not, then only you can find. For suppose I'm having CaCO3 gives rise to CaO plus CO2. What is the relation between Kp and Kc here in this reaction? So what I know that Kp is equals to Kc into RT to the power of delta N. This is solid, and this is gas. Okay, so I can write Kc into RT to the power of 1 because only 1 mole of product of the gas is there. Remaining all are solid. You can see this is solid, this is solid. So only 1 mole of gases product is there. So Kp is equal to Kc into RT. Okay. So relation you have to know that Kp is equals to Kc into RT to the power of delta N. Now, if you take the cases, suppose case 1. If delta N is equals to 0, if delta N is equals to 0, just like H2 plus I2 gives rise to 2HI. These all are gases, suppose. Then delta N value will be equals to number of moles of products are 2, number of moles of reactants here 1 mole, 1 mole, 2 moles. So 2 minus 2 is equal to 0. So if delta N is equals to 0, then Kp will be equals to Kc because here RT to the power of 0, anything to the power of 0 will be equals to 1. So Kp is equals to Kc. Okay. Next, case 2. If delta N is greater than 0, delta N is greater than 0 means I can write Kp will be greater than Kc. If delta N is greater than 0, then Kp will be greater than Kc. Why? Because if you see, suppose delta N value is equals to 1, then I can write Kp is equal to Kc into RT. Means Kp is greater than Kc here. Okay. Coming to case 3, if suppose delta N is less than 0, delta N is less than 0, then I can write Kp will be less than Kc. Suppose delta N value is equals to -1, then I can write Kp is equals to Kc into RT to the power of -1. That I can write Kp is equals to Kc by RT. That means Kp is less than Kc. So these relations you have to remember. Okay, so what are the relations we are having? Only one thing. Remember that Kp is equals to Kc into RT to the power of delta N, and how to find when delta N is equals to 0, delta N greater than 0, and delta N less than 0. If you can understand all of you, then we will move to the questions. Some questions we will do, or else if you not understand, please let me know. Understood? Okay. No doubt? Clear. Okay. Coming to the question, suppose all of you take out a pen and paper is very important, because from here onwards everything will be problems. A reversible reaction having two reactants in equilibrium. A reversible reaction having two reactants in equilibrium, if the concentration of the reactants, if the concentration of the reactants are doubled, if the concentration of the reactants are doubled, then the equilibrium constant will be option 1 becomes 1/4, option B also be doubled, option C be half, and option D remains the same. A reversible reaction having two reactants in equilibrium, if the concentration of the reactants are doubled, then the equilibrium constant will be. What do you think? Yes, correct, Nandini. Good. What do you think? What is the answer? No need of having some all the mind blogging. No, 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 no. Yeah, you thought like that. It is good. No Dheeraj, no Karunya, no Afya. Actually, the equilibrium constant will not change. It will remains the same. See what the logic is there. What I have seen, what I have the logic in the question, that if the concentration of the reactants are doubled, what about the products then? Here not given about the products, only the concentration of the reactants have been doubled, it is said. And what I'm saying, equilibrium constant, a constant value will never be changed. You know, constant is a constant. We are having the universal gas constant, R value. Should R value will change anywhere? No, R value will never be changed like that. So if the concentration of the reactants have been doubled, equilibrium constant will not change. It will remain the same only. It's a simple logic you have to see. Okay. Next one. On a given condition, the equilibrium constants, the equilibrium concentration of Hi, H2 and I2 are 0. Yeah, I told Kc is equals to Kf by Kb. Kc is equals to Kf by Kb, but like that, because it is an equilibrium constant, of course Kf is a constant, Kb is a constant. Yeah, constant by constant is a constant. Constant, should constant will change? If anything is there, just have a logic there. Constants are, constant value will never be changed for any reaction. So 0.80, 0.10 and 0.10 mole per liter. The equilibrium constant for the reaction H2 plus I2 gives rise to 2Hi. This is the reaction. Equilibrium concentration have been given for HI, H2 and I2. What is the Kc value? So options are 12, 0.8, 8 and D 64. What is the answer now? What is the Kc value for this reaction? Yes, correct, Karana. Good. Yes, Nandini. What is the value of Kc? Dheeraj and Afia? Kc is equals to concentration of HI whole square by concentration of H2 into concentration of I2. So concentration of HI, how much it is given? For HI is 0.80. So 0.80 whole square by H2 is concentrate 0.10 into 0.10. So that is, I can write 64 into 10 power of minus 2 and this one also 10 power of minus 2. So these to get cancelled, we'll get 64 as our answer. So answer is 64. Next one. In the reversible reaction, A plus B gives rise to C plus D. Okay. The concentration of each C and D at equilibrium was 0.8 mole per liter. Then the value of Kc is, so options are 0.64, option B 16.0, option C 1.6, option D 6.4. So at equilibrium concentration C and D as 0.8. Now, how to do this type of question? So the reaction is A plus B gives rise to C plus D. Initially, suppose A is 1 mole, B is 1 mole, or concentration of A is 1, concentration of B is 1. So initially C will be 0, D will be 0. This is initially. Now at equilibrium, it is 0.8 mole per liter. This is also 0.8 mole per liter. So means 1 minus 0.2, this will be 0.2. You got B as option. Yes, correct, Nandini. Okay. So Kc will be is equals to 0.8 into 0.8 by 0.2 into 0.2. Like this, you can calculate. So this will be 0.64 and this is 0.04. You will get 16 as your answer. Okay. Next one. If in the reaction N2O4 gives rise to 2NO2. This is the reaction I'm having. Alpha is that part of N2O4 which dissociates. Then the number of moles or total number of moles at equilibrium will be. Then the total number of moles at equilibrium will be. Options are 1 plus alpha, option B 1 minus alpha whole square, option C is 3, option D is 1. So N2O4 gives 2Na2, the reaction is given. Alpha is a part of N2O4 which dissociates. Then the total number of moles at equilibrium will be. Yes, correct, Nandini. Remaining all, please give the answer. What will be the answer? Yes, Karanya, good. Dheeraj and Afia, what do you think? So, okay. Initially, suppose 1 mole is there. This is 0 mole. See how we are writing initially, because only reactant will be present, means I mean to say starting of the reaction. Only reaction is present. So I am taking 1 mole and product will not be there. So it is 0 mole. Now alpha is a part of dissociation is telling, means of N2O4. So 1 minus alpha, because alpha has been dissociated. So now at equilibrium what happens? At equilibrium 1 minus alpha moles of N2O4 is present. So here how much? Because 2 moles of NO2 is there. So 2 alpha will be formed. 1 minus alpha dissociated. So 2 alpha will be formed. So total number of moles at equilibrium. Total moles will be is equals to 1 minus alpha plus 2 alpha. That is equals to 1 plus alpha. What to understood? So what I am telling that, see, initially suppose 1 mole of N2O4 is there, NO2 is not there. After equilibrium has been attained, since alpha is a part of dissociation, so alpha has been dissociated from N2O4, so 1 minus alpha, and here since 2 moles of NO2 is been produced, so 2 alpha number of moles of NO2 will be there at equilibrium. So total number of moles 1 minus alpha plus 2 alpha is equals to 1 plus alpha. Any doubts? Any doubts? Okay. For the system, A gas plus 2B gas gives rise to C gas. The equilibrium concentration are, for A it is 0.06, for B it is 0.12, and for C it is 0.216, all mole per liter. The Kc is how much? Options are 4 into 10 power of minus 3, option B 125, option C 416, and option D 250. Tell me the answer. 0.06, 0.12, 0.216, the Kc value will be. Yes, Karna, good. How much will be the Kc value? Just multiplications are there, you have to do. Yes, Nandini, good. No, Dheeraj. Twelve, 12s are 12 ones are 12, 96. 12 is a 96. 6 threes are 3, 4s are. So 1 by 4 into 10 power of minus 3 plus 4 plus 1. Getting 250. Concentration of C by concentration of A into concentration of B square. Okay. Then concentration of C is 0.216. Concentration of A is 0.06 into concentration of B is 0.12 whole square. This is 216 in 10 power of minus 3, 6 into 10 power of minus 2. This is 0.144, sorry, 0.0144 10. So this one I can write 144 into 10 power of minus 4. So that means 216 into 10 power of minus 3. So I can get cancel here. 12 12s are 12 18s are 6 3s are 3 4s are. So that is 1 by 4 into this 10 power of minus 6 means 10 power of 3. So 1000 by 4 it is equals to 250. Yes, so you will get 250 as the Kc value. Okay, I have not multiplied it. Okay, so answer is 250 Kc value. Next one. Yeah. Equilibrium concentration of HI, I2 and H2 is 0.7, 0.1 and 0.1 molar respectively. The equilibrium constant for the reaction I2 plus H2 gives rise to 2HI. Yeah. So equilibrium concentration has been given. Find the equilibrium constant for the reaction. So options are 36, option B 0.49, option C 49, and option D is 0.36. Correct, good. How much? Yes, Nandini, correct. Yes, Afia, correct. Good. So Kc for the reaction I can write as concentration of Hi square by concentration of H2 into concentration of I2. So that is 0.7 into 0.7 by 0.1 into 0.9. That will be equals to 49. Okay. Next. In the reaction, A plus B gives rise to 2C. At equilibrium, the concentration of A and B is 0.20 moles per liter each, and of C is 0.60 moles per liter. Okay, the Kc value is option A 2.4, option B 9, option C 4.8, and option D 18. So what is the Kc value for the reaction? Yes, correct, Nandini. Yes, Karunya, correct. How much you are getting the Kc value? Or Kc is equals to concentration of C square by concentration of A into concentration of B. That is 0.6 into 0.6. I can write it is 0.2 into 0.2, because 0.6 whole square, no, that's why I written 0.6, 0.6. This is 3, 3. So 3 into 3, I will get 9 as the value, Kc value. Okay, so next one. In the reaction, PCl5 gives rise to PCl3 plus Cl2. The equilibrium concentration of PCl5 and PCl3 are 0.4 and 0.2 mole per liter. If Kc is equals to 0.5, then the number of or the concentration of Cl2 is, options are 1.0, 2.0, 0.5, and option D 1.5. So reaction has been given, equilibrium concentrations have been given, Kc value is given, finding us to calculate the concentration of Cl2. Yes, Karunya, correct. Good. Yes, Nandini. Oh, Afia and Dheeraj, what you are doing? Not able to find the answer? Yes, Dheeraj, correct. So Kc is equals to concentration of PCl3 and the concentration of Cl2 by concentration of PCl5. Yes, Afia, good. So Kc is 0.5, PCl3 is 0.2 into Cl2 by concentration of PCl5 is 0.4. So this is 2 into 0.5. I can have Cl2 is equals to 1. So 1 mole per liter is the concentration of chlorine. Next, partial pressure of O2 in the reaction 2Ag2O 4Ag plus O2. This is solid, this is solid, this is gas. So options are 3 root Kp, option B 2 Kp, option C Kp, and option D root Kp. No. Nandini, you are correct. After no. See here the states. Yes, Karunya correct, Dheeraj correct. So Kp will be is equals to partial pressure of Ag into partial pressure of O2 by partial pressure of Ag2O. But Ag and Ag2 are solid, so that is equals to 1. So Kp will be is equals to partial pressure of O2. So partial pressure of O2 is the reaction will be equals to Kp. Next, the equilibrium constant of a reaction is 300 if the volume of the reaction flask is tripled. The equilibrium constant will be. Options are 100, option B 200, option C 900, and option D 300. The equilibrium constant is given as 300. If the volume is tripled, then the equilibrium constant will be. Yes, Nandini, good, very good. Dheeraj, good. Just a simple logic. No need of calculations and all those things. Simple logic, you will get the answer. Yes, Afia, good. So the answer is same. The equilibrium constant will not change with the volume because already I told one question we have done. That constant is constant, will never change. That's why here also equilibrium will not change. So answer is again 300. Okay, next. If the equilibrium constant for the reaction N2 plus 3H2 gives rise to 2NH3 at 750 Kelvin is 49, then the equilibrium constant for the reaction NH3 gives rise to half N2 plus 3 by 2 H2 at the same temperature will be. So options are 7, 1 by 7, 49 square, and the option D is 1 by 49. So N2 plus 3H2 be 2NH3, 750 Kelvin, equilibrium constant given as 749. Good, Nandini, good, correct. So for that reaction, for this reaction, what will be the equilibrium constant? Yes, correct, Karun. No, Dheeraj. The answer is 1 by 7. See here, multiplication with 1 by 2 has been done. But I've said if multiplication have been done, then we have to go to the power. The stoichiometric coefficient, with the number from which we have multiplied, we have to take to that power. So answer is 1 by 7 to the power of, 1 by 49 to the power of half, or root 1 by 49, that is equals to 1 by 7. Next, at 300 Kelvin, the equilibrium pressures of CO2, CO and O2 are 0.6, 0.4 and 0.2 atm Kp for the reaction 2CO2 gives rise to CO plus 2CO plus O2 is, options are 0.0533, option B 0.089, option C 0.0533, and option D 0.100. Find out which one, first and third. Okay, okay, understood. Okay. No, Karunya. No, Nandini. Yes, now correct. No, Afia, no. Karunya is correct now. You will get the answer as 0.089. delta N, the change in number of moles for the reaction. C12H22O11 solid plus 12O2 gas, 12CO2 gas plus 11H2O liquid. Options are -1, 4, 0, and 2. Delta N for the reaction. Yes, Nandini, correct. No, Akya. Dheeraj, correct. Only delta N means only the number of moles of gaseous products minus number of moles of gaseous reactants. So how many gaseous products are there? This is liquid. This is the gas. So 12. How many gaseous reactants are there? 12 here again. Here is 0. Only one mole is there. There also solid is there. So 12 minus 12, that is equals to 0. So delta N value is 0 for the reaction. Okay, next for the reversible reaction, N2 plus 2H2 gives rise to 3NH3. 3NH3. Okay. At 500 degrees centigrade. 2NH3. The value of Kp is 1.44 into 10 to the power of -5 when, okay, the value of Kc is, find the value of Kc. The options are 1.44 into 10 power of -5 by 8.314 into 773 to the power of 2. Option B 1.44 into 10 to the power of -5 by 0.082 into 500 to the power of -2. Option C 1.44 into 10 power of -5 by 0.082 into 773 to the power of -2. And option D 1.44 10 power of -5 by 0.082 into 773 to the power of -2. This is +2. All are gases. Yes, correct, Karan. This is D, sir. This is D. This is -2. Now correct. No. No. First one is correct, Karan. Okay, okay. Correct, correct, correct. Kp is equals to Kc into RT to the power of delta N. Just find this one, you will get the answer. Okay, but see the value, Dheeraj. R value. Because partial pressure always be in atmosphere, no? So R value will be no. So Kp is equals to Kc into RT to the power of delta n. Delta n value will be 2 minus 4, that is minus 2. Kp given as 1.44 into 10 power of minus 5 is equals to Kc into RT to the power of minus 2. So I can write Kc is equals, or this one we can write 1.44 into 10 power of minus 5 is equals to Kc by RT whole square. But here asking to find the value of Kc. So that's why Kc is equals to 1.44 into 10 power of minus 5 or 0.0821 into temperature how much, 500 means 773 to the power of 2, or this one I can write 1.44 10 power of minus 5 by 0.0821 into 773 to the power of minus 2. Okay, so answer is option C. Understood? Any doubts? Any doubts you can ask? Okay. Okay. Yeah, I will provide the DPP also, don't worry. So the reaction between N2 and H2 to form NH3 has Kc is equals to 6 into 10 power of minus 2 at 500 degrees centigrade. The value of Kp is, option is 1.5 into 10 power of minus 6, option B 1.5 into 10 power of minus 5, option C 1.5 into 10 power of 5, and option D 1.5 into 10 power of 6. So Kc has given, find the value of Kp. It's very easy. First write the reaction, then find the Kp Kc values. What is the delta n value here? Minus 2. No. Since small mistake. Almost correct. Small mistake. Small mistake after. Yes, Nandini, correct. So calculation parts are difficult. Formulas, logics, you have to know, you have to apply all those things. Almost only the calculation part will be difficult to you. I also know, but you have to do practice. Then only you can find the solution for you. You have to practice, 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 and more. Because you go to our why about DBP. I will show you how to practice the questions once the class is completed. We'll go to that section. Okay, so the answer you will get is 1.5 into 10 power of minus 5. Kp value is 1.5 into 10 power of minus 5. Okay, yeah, so here we'll close the class. We'll end the session for today.